Thanks. Okay, sorry about that. Usual startup problems. Okay, so let me explain you everything about Einstein Probe. Well, this is a slide that was shown earlier. As I said, I'm also working on other projects. 25% of my time is on Einstein Probe, which is more like the science policies or science politics rather than the data analysis. And I'm the ESA project scientist. So what is Einstein Probe? Well, it's a mission, Chinese mission basically, together with ESA and also CNES is involved in NPE. So it has basically two instruments, a wide field X-ray telescope containing 12 modules of lobster eye optics, so very wide field of view, of one steradian of the 12 modules. And then there are two X-ray telescopes, basically two Rosetta type telescopes, one built by NP and one provided by ESA. So it was launched this year, so it's a relatively new mission, so not too many problems like Swift. These were the main scientific objectives, survey the soft X-ray transients, new soft X-ray transients, all the ones which appear again, and variability of the known X-ray sources. But the main thing was discover new transients with compact objects like TDEs or any other gamma ray burst, any other objects, and also to find the electromagnetic counterparts to gravitational wave sources. Well, the first two objectives have already been satisfied. We haven't found electric EM counterpart yet. This has been alluded to already. So there are various observation modes. Basically, there is a survey, which just you cover in 3 orbits, you cover half the sky. So you do 3 pointings per orbit, 20 minutes each. And you cover the whole sky in X-rays in half a year. And then there are targets, autonomous follow-ups like Swift. So if there is a trigger, the X-ray telescopes point to the source, to the new transient. We can also do targets of opportunity with both the instruments if people are interested in triggering. And of course, there's also calibration modes. So last half a year, what did Einstein Probe do? So this is sort of the first light. It's not very well visible, but basically here you see all the modules. It's pointing to the galactic center. It basically covers the galactic center in one go. Here's, for example, a SCOX1. Here's a zoom in. So there's SCOX1. It's a bit too bright, but here you see basically a lot of the sources in one go popping up. So this is a 40 kilosecond observation, and you see the very wide field of view, which is mostly very important to catch any transient. So here's the first light of the fast X-ray telescope. It has basically a 1 by 1 degree field of view. Very nice image of the Purpose A supernova, and you can do very nice spectra, X-ray spectral analysis as well, especially from 0.5 to a few keV. So this is the first transient discovered with Einstein Probe already in the commissioning phase. That was on 19th of February. So here you see the transient moving up. So we moved with the time resolution of about 33 seconds. Sorry, Phil.
I'm just trying to get the light off, see if you can see it.
Sorry. Yeah, that's better. So let me quickly show this image. So you really see the nice what Einstein Probe can do. By the way, you all know Einstein, so I don't know why they named it Einstein Probe. I mean, probably because they want to be popular.
Already an X-ray telescope named after Einstein.
Yeah, I know. I mean, there's also Einstein telescope coming up. So
yeah, but
then they dropped the X-rays there. So yeah, so this transient had a duration of about 200 seconds. I mean, the ATOL they sent out was their first alert. There was later a sub-threshold gamma ray burst signal found undetected by XRT 40 hours later. No optical counterpart, but the follow-up was quite late. So this is probably an X-ray-rich gamma ray burst, which was also probed by, for example, Paris-Saclay wide field cameras in the 80s, early 90s. So, as I said, there is also an automatic follow-up of transient that was started just before summer. And the first successful test was on the 5th of June, my birthday. I don't know why they choose that day. So they use either the Chinese satellite link with Baidu, but they also use the CNES VHF networks, which is also used by SWAN. The downlink was within minutes, and it triggered automated observation with the FXT within 1 minute. So they found, so this is the WXT error region, and they found the afterglow with the FXT, but it was just ordinary flare star. So the quickest multi-wavelength, I mean, I don't call it multi-messenger because that includes neutrinos and gravitational waves. So this is a true multi-wavelength follow-up on the, so yeah, on the 14th of April. So within a couple of hours, a lot of optical observatories were already observing, and a source was found at the same position as the fast follow-up X-ray telescope. And they found the origin of the source was the host galaxy of a redshift of 0.41. On the 15th of March, I mean, I'm not doing it in a chronological order. There was another transient in March, so it was just at the side of one of the modules. There was a follow-up with the follow-up X-ray telescope was detected. There was then optical and radio follow-up. They found the galaxy with the redshift of 4.9, which is quite far away. Oh, this is the light curve. So this is the one, the WXT light curve, and the crosses are from Swiftblatt and Corners wind. You see there's quite sometimes some anti-correlation between the X-rays and gamma rays. But the main thing is if you would put it, well, it would still be detectable if you put this transient at redshift of 7.5. So this is quite a nice potential of Einstein Probe of detecting high redshift gamma ray burst, which is kind of sort of holy grail. And also Theseus, which is the ESA mission, hopefully flying in 10, 15 years to do the same thing. Well, at least finding high redshift gamma ray burst. There they have X-ray detector, gamma ray detector, and an infrared detector. So you can, as soon as the transient is detected, they slew to the source and try to find the redshift with the infrared telescope. So here is a list of, examples of transients detected by Einstein Probe, and also LAIA, which is a pathfinder with one module which flew in 2019. And you can see whether, for example, whether there was a gamma ray counterpart or not. Many don't have gamma ray counterparts, so you might think these are X-ray rich gamma ray bursts. So here are some light curves of some of the transients I already showed. They pop up and then fade away most of the time. But as I said, only 1/3 of them have gamma ray counterparts. So what are all the others, the 2/3 of the transients? So probably X-ray rich gamma ray burst, or we don't know yet. Yeah, I think we need quicker follow-ups at other wavelengths, I guess. So up to a few weeks ago, 1 or 2 months ago, Einstein Probe has already detected more than 5,000 sources. I mean, not only transients. So a lot of them are AGNs and flare stars, but we also find some cataclysmic variables, supernova remnants, X-ray binaries, etc. and 40 transients already within half a year with high signal to noise. We also search for electromagnetic counterpart, haven't found it yet. This is also one of the objectives. On April 22, it was probably a neutron star plus binary black hole merger at 240 megaparsecs. The Einstein Probe observation started in 3 hours, but we only set upper limits. And so here you see basically the field of view of the WXT, and this is the tiling search done by the FXT. And here was the best position. But it doesn't only look for transient. It also, I mean, when you cover half the sky in a few orbits, you can also monitor your favorite source, X-ray binaries, blazars, AGN, whatever. So this is already quite a large archive of monitoring. So to conclude, I mean, since half a year, well, it was launched 9 months ago. It's doing great. I mean, the performance is even as good as on ground, and that's it's very nice. I mean, for a new detectors like the Lobstry. Well, it has detected various transients, flaring stars, anything. The nominal science observations started in July. So if you want to have, if you want to do TO follow-up, there is a web page available or in the making. A week ago it was not there yet, but they really have startup problems and trying to improve on things.